Hello students, I am Sachitraka. Welcome to Cars Physics. We are continuing kinematics and we are discussing motion in a straight line. In just previous lecture, means in lecture number 14, I have discussed acceleration time graph and also we have discussed the all concepts of acceleration time graph and the output of acceleration time graph, and also we have discussed some numericals on the basis of acceleration time graph. And before that, means in lecture number 13, we have discussed the fundamental concepts of displacement time graph and velocity time graph. Okay, in this lecture we will discuss some fundamental numerical on the basis of displacement time graph. Okay, basic numericals on the basis of displacement time graph. So numericals are fundamental questions on ST graph. Numericals on ST graph. Okay, so let's just recall about ST graph, displacement time graph. Okay, so as we have discussed, from displacement time graph we can find velocity of a body. From displacement time graph we can calculate velocity of a body, and as we have discussed, slope of graph, slope of displacement time graph gives us velocity. Thus, magnitude of velocity ds by dt, and that's equals to tan theta. So tan theta is slope of graph, and slope of graph gives us velocity of a body. Okay, of course we can discuss on the basis of same theory distance time graph. Okay, but the basic difference between distance and displacement is vector, distance is scalar. So distance can never be negative, but displacement can be negative. And in accordance with that basic, velocity can be negative because it's a vector quantity. Okay, and speed can never be negative because distance can never be negative. Okay, then this is our basic concept. We can calculate velocity from slope of displacement time graph. Okay, then as we have discussed, just I am recalling you, on x-axis we are showing variation of time, and in y-axis we are showing variation of displacement, and this was our first graph, means a body is at rest. If a body is at rest, then the graph is a straight line parallel to time axis, and here tan theta is 0, means theta is 0 degree, means the graph is a straight line parallel to time axis. Okay, then again displacement time graph. A body is moving with uniform velocity. Again, if velocity is uniform or constant, then tan theta is constant. If tan theta is constant, v is constant, tan theta is constant, and theta is constant. So what is theta? Theta is angle made by the graph with time axis. Okay, so to get instantaneous velocity ds by dt, if the graph is a curve, then we can draw a tangent at the required point, or when at the instant we require velocity, instantaneous velocity. So here theta is constant. So the graph is a straight line making a constant angle with time axis. Wherever you see angle is theta. So theta is constant. Okay, the graph is a straight line making a constant angle with time axis. Then a body moving with acceleration, for accelerated motion magnitude of velocity increases and slope of graph increases, and if tan theta increases, then theta increases. Then here the value of theta increases because slope increases. So in this case the graph is a curve bending upward. Okay. If you draw a tangent at this point, means at this required time, then instantaneous velocity, direction of instantaneous velocity, tan theta makes an angle, theta is angle made by the tangent with time axis is theta 1. If you draw a tangent at this point, then here theta 2 and so on, means theta increases continuously. Okay. And as we have discussed, this graph can never be like this, means the graph can at any instant, if you draw a tangent, then this angle is 90 degree and this graph is not possible because slope can never be infinite. 90 degree means tan 90 is infinity. So displacement time graph gives us velocity, so velocity can never be infinity. Okay. Then a body moving with retardation. In retarded motion, magnitude of velocity decreases and tan theta decreases and also theta decreases. So in this case, again the graph is a curve bending downward. So if you see here theta is parallel to time axis, this line, here theta is theta 1, and here if you draw another tangent, then angle is theta 2. Theta is decreasing because body is in retarded motion, means magnitude of velocity decreases. Okay. These are fundamental aspects, and we know positive or negative displacement is vector quantity. So this is negative quadrant and this is positive quadrant. In accordance with the direction of velocity, we may represent the graph. Okay. Then some numericals, these were fundamental discussion. Now, some numericals. Okay. Question number 1. Suppose displacement time graph is given like this. This is 0. Two basic questions. These are two straight lines making angle theta 1 and theta. Let theta 1 is 30 degree and theta 2 is 60 degree. And as we know, along y-axis we have shown variation of displacement and along x-axis we have shown variation of time, and rate of change of displacement means the graph under ST graph means under displacement and time. Displacement time graph gives us velocity. So these are two straight lines making constant angles with time axis. Then these two graphs represent two different velocities. Let this velocity, this graph represents velocity v1 and this graph represents velocity v2. Okay. Then it is asked, which one is more? Means v1 and v2, two velocities are represented by using this graph. Then magnitude of which one is more, v1 or v2? And also it may be asked, find ratio between the velocities c. If we consider velocity v1, magnitude of velocity v1 is tan theta 1, means v1 is equal to tan 30 degree, theta 1 is 30 degree, and v1 is equal to 1 by root 3. And in similar way, v2 is equal to tan theta 2, that's equals to tan 60, and V2 is equal to root 3. Okay. Then if it is asked to calculate the ratio between V2 to V1, then this is equals to root 3 divided by 1 by root 3, and our answer is 3:1. Two basic questions. Okay. Then question number 2. Is it clear? Is it clear to all? Okay. Question number 2. Displacement time graph. Time along x-axis, displacement along y-axis, and this is 0. Okay. The graph is like this. The graph is like this. Okay. The values, we may take arbitrarily the values corresponding to different points. Here time is 0 and position is 0, and this shows let 50 meter, and here this is 100 meter, and this time is let 5 seconds, and this time is let 15 seconds. Let's take 15 seconds, and here this time is 20 seconds, and finally this time is 30 seconds. Okay. Then it is asked, see, this is a displacement time graph. Okay. And it is asked, find instantaneous velocity at t is equal to 2 seconds, in bit B at t is equal to 7 seconds, and at instantaneous time 17 seconds, and finally at instantaneous time 25 seconds. From the given graph, we have to find instantaneous velocity at different instant of time at 2 seconds, 7 seconds, 17 seconds, and 25 seconds. Okay. And at t is equal to 2 seconds. Thus, see, from 0 second, here time is 0, here position is 0. From 0 second to 5 second, the graph is a straight line making a constant angle with time axis. Let that angle is θ1. And now we have discussed, if the graph is a straight line making constant angle with time axis, then velocity is constant. Then velocity is constant means magnitude of velocity and direction of velocity both are constant. Okay. Then here velocity is let v1, and velocity is tan theta, here θ1, and here velocity is tan θ1. See, this is a right angle triangle, this angle is 90 degrees. From this right angle triangle, tan theta is equal to perpendicular upon base. Here perpendicular is 50 meter and base is 5 seconds, and our answer is 10 meter per second. And bit B at t is equal to 7 seconds, you just see here slope of graph is tan θ1. At this instant t is equal to 2 seconds, but at 7 seconds the graph is a straight line. From 5 seconds to 15 seconds, the graph is a straight line parallel to time axis, means here theta is 0 degree. Parallel to time axis, so theta is 0 degree. And at t is equal to 7 seconds. If velocity we do take v2, then v2 is tan 0 degree, that's equals to 0. Means here the body is at a given position at a distance 50 meter and the body is at rest. From 5 seconds to 15 seconds the body is at rest. Then with C at t is equal to 17 seconds. See, this is 15 seconds, this is 20 seconds. Let here time is 17 seconds. We have to find the instantaneous velocity at t is equal to 17 seconds. See, considering 17 seconds here, also the graph is a straight line and this line is parallel to time axis, and here the graph makes a constant angle with time axis and that angle is theta 2. And here velocity, let v3 is equal to tan theta 2, and considering this triangle, this angle is 90 degree and tan theta is perpendicular upon base, and here perpendicular is 100 meter minus 50 meter, so this is 50 meter, and this interval of time is 15 second to 20 second, means this time interval is 5 seconds. So tan theta 2 is 50 meter divided by 5 seconds is equal to 10 meter per second, and finally with D at t is equal to 25 seconds. See, from 20 second to 30 second, from 20 second to 30 second, at 20 second position is at 100 meter and at 30 second position is 0. Here position is 0. When time is 30 second, position is 0. Means again the the body has returned back to initial position. The body was in initial position when time is 0, and finally the body comes back to initial position when time is 30 seconds. So, body moves with uniform velocity from 0 second to 5 second, then remains at rest from 5 second to 15 second, thereafter from 15 second to 20 second. Body moves with uniform velocity, and from 20 second to 30 second, again velocity is uniform, but body returned back to its original position. So, here slope of graph is negative. Here slope of graph is negative, and if you take here velocity is v4, you just see this region from 20 second to 30 second. Okay. First I am taking negative slope, or you may take on the basis of this angle. This angle is 90 degree, and automatically it will come negative. See, final position is 0. Initial position is 100 meter minus 100 meter. Final position is 0. Initial position is 100 meter divided by interval of time from 20 second to 30 second, means 30 second minus 20 second, that's equals to 100 by 10 minus 100 by 10, so minus 10 meter per second. Here it shows that slope is negative, and by calculating tan theta, b4 is equal to tan theta 3, let this angle is theta 3, automatically we are getting negative slope. Okay. Next question. Fundamental question. Let a graph between displacement and time is given like this. This is displacement, this is time. Okay. Suppose this is the graph, and it is asked Draw VT graph. Draw VT graph for the given ST graph. ST graph is given. From this graph we have to draw velocity time graph. See, the graph is a curve and this is time axis. Just draw a tangent. Here tangent makes a constant angle with time axis, and here tan theta is positive, means slope is positive. Okay, and velocity time graph now made easier. Time velocity. Okay, and here it makes a constant angle with time axis. So slope is positive, tan theta is positive. So velocity is increasing uniformly. Graph is a curve, velocity is increasing positively, and according theta will go on increasing if this is a curve. Okay. Finally, next question. It is also easier question. We have question number 5. Okay. The question is like this again. Displacement, and this is time. The graph is a straight line making constant angle with time axis. This refers to 20 meter. Position is 20 meter. This is 0, and this time is like 10 seconds. Thereafter, parallel to time axis, let this time is 20 seconds, and then up to this. Let this time is 30 seconds. Okay. This time is 30 seconds. This is O. Let this is A. This is B. This is C. Okay. Then it is asked, find velocity in the region. First bit OA, second bit AB, third bit BC. We have to find velocity in the given region OA, AB and BC. Too easy, very easy. First A bit. If you see the graph OA, it is a straight line, makes constant angle. Let this angle is theta. If the graph is a straight line between displacement and time, if the graph is a straight line making constant angle with time axis, then velocity is constant, and that's equals to tan theta 1. And from this right angle triangle, tan theta 1 perpendicular upon base, here perpendicular is 20 meter and base is 10 second. 0 to 10 means 10 minus 0, this is 20 minus 0, this is 10 second minus 0, and finally it is 2 meter per second. Then bit B in the region AB. See, in the region AB, the graph is a straight line parallel to time axis, means here theta is 0. So here velocity is tan 0 means 0. Okay. You may take this is theta 2. Theta 2 is 0, so tan 0 is 0. Then bit C in the region BC. Again, BC is a straight line making a constant angle, let theta 3 with time axis. This is parallel to time axis and angle is theta 3, which is constant. Then here velocity is tan theta 3. See, this is the right angle triangle. This is perpendicular 90 degree. From this right angle triangle, tan theta is perpendicular upon base O. I have not given this. This is C. Okay. Let this value is 40 meter. Okay. Then this perpendicular is 40 meter minus 20 meter means this perpendicular is 20 meter. Then tan theta t is perpendicular is 20 meter and base. This interval of time is 30 second minus 20 second. You may write it. 20 meter means 40 meter minus 20 meter divided by interval of time. This is 30 second, this is 20 second, 30 second minus 20 second. Again 20 by 10 means 2 meter per second. Too easy, very easy questions. Okay, next question. Next question. Question number 6. Suppose it is given a body is thrown in vertically upward direction and it returns back to initial position. Draw first with displacement, time graph, bit B, distance, time graph. The body is thrown in vertically upward direction and again returns back to initial position. We have to describe this situation by taking the help of displacement time graph and distance time graph. Let's first discuss displacement time graph. This is your situation. Body is thrown in upward direction. Let initial velocity given to the body in vertical upward direction is u when time is 0. The body goes up. The body goes up, and while moving up, acceleration due to gravity retards its motion. And here we may take acceleration due to gravity means its value is constant but it opposes the motion. So at highest position its velocity becomes 0 and again it returns to the initial position, and at the instant when it returns initial velocity is 0 at the highest position. So let the body has moved total height h, and this time to reach at highest point is time of ascent, and time taken by the body to return back from highest position to initial point is time of descent. And as we know, if air resistance is neglected, then time of ascent is equal to time of descent is equal to u by g. As per equation, just you see time of ascent v is equal to u plus at. Time of ascent, final velocity is 0, u in place of a minus g, time of ascent, so time of ascent is u by g. And also we have discussed, we have proved that time of ascent is equal to time of descent. And those students who have not followed the video, we have discussed in brief complete lecture on motion under gravity. Complete lecture on motion under gravity, and I hope you have seen the lecture, and I have discussed all the concepts on the basis of motion under gravity. Okay, and there we have discussed if air resistance is neglected, time of ascent is equal to time of descent, and also we have discussed velocity of projection is equal to velocity of striking, which will be discussed in next lecture, means numericals on VT graph in next lecture. Okay. Here we have to draw displacement time graph. You just see first bit. Along x-axis we have represented variation of time, along y-axis we have represented variation of displacement. See, when the body is thrown in vertically upward direction, when the body is thrown in vertically upward direction, then its velocity is u. Its velocity is u, and its position is 0. Here position is 0, and final position is s, means h. When the body is thrown in upward direction, at the instant the body is thrown, time is 0 and position is 0. Is it clear? And body moves up, and the body moves up. But see, what is the nature of motion? I am writing here, while moving upward. While moving upward, the motion is uniformly retarded. G is constant, u initial velocity in upward direction and acceleration due to gravity in vertically downward direction. So if acceleration is opposite to the direction of velocity, then it is a retarded motion, and since g is constant, it is uniformly retarded motion. If motion is uniformly retarded, then velocity decreases. Velocity decreases. Okay, but position from S0 to S is equal to H. Okay. So we are drawing displacement time graph. Initial position is 0. Initial position is 0 and time is 0. Okay. Initial position 0, time is 0. And motion is uniformly retarded. And as we have discussed from ST graph, if velocity decreases, then the graph is a curve bending upward. If velocity decreases, means in uniformly retarded motion, velocity decreases, the graph is a curve bending downward. And see, at highest position velocity is 0. Okay, but position is h, means maximum height reached by the body is h. Is it clear? So initial position is 0, time is 0. The graph is a curve bending upward, and this is the highest position, h. This is the highest position from 0 to h. Okay, displacement is h from 0 to h, and this time is time of ascent. Okay, and here position is h, time taken by the body to reach the highest position is time of ascent. Okay, suppose time of ascent is t, so this time is t from 0 to t. And here if you draw a tangent here, then slope is 0. Theta is 0 degree, means parallel to time axis. So at highest point velocity is 0 and the graph is a straight line parallel to time axis, so slope is 0, which shows at highest point velocity is 0. Okay, here velocity goes on decreasing and position increases from 0 to h. At highest point slope is 0 degree, so velocity is 0. Here velocity decreases, but from highest point the body again returns back to the initial position, and initial velocity is 0, and acceleration due to gravity is in downward direction. So, while moving downward, motion is uniformly accelerated. Motion is uniformly accelerated and velocity increases. Moving downward, velocity increases, but final displacement is initial position. Means total displacement is zero. Okay. During time of descent, the body has travelled same magnitude of displacement, moving upward edge and returns back in downward direction through same distance h. Okay. But time taken is same, means time of ascent is equal to time of descent, and final position is same as that of initial position. So what will happen now? Body will return back and finally reach out initial position. So this is time of descent again t. So total time is 2t. This is t, this is t. Initial position 0 and final position is also 0, and 2t is equal to time of flight. Total time of flight is 2t. So initial position 0, final position 0. Initial position 0, final position 0. So this is about displacement time graph for a body thrown in vertically upward direction and returns back to initial position. If the magnitude of initial velocity is given, then we can calculate time of ascent as well as time of descent. Means this is equals to u by g, this is equals to u by g, and total time is 2u by g. Total time is 2u by g. This is about displacement time graph for this given situation. And then distance time graph. Distance time graph. Okay, here you can observe here velocity position increases and final position decreases. Okay, then bit B. Bit B, distance time graph. Very easy, you just see. As we have discussed, time of ascent is equal to time of descent, distance. Yes. And this is time. Here, 0. Position is 0, time is 0. As we have discussed in previous case, displacement time graph. And here, distance increases c. If a body is thrown with initial velocity u, then it goes to highest position. At highest position, velocity is 0 and distance covered is h. And again the body returns back. Initial velocity 0. Okay. And again distance is h, this distance h, and this distance is also h. Again, time of ascent is equal to time of descent. So total distance is 2h. Total distance is 2h. Okay. So in first case, velocity, it's the graph between distance and time. So distance goes on increasing. Okay. But motion is retarded, upward motion is retarded. Distance goes on increasing, the similar graph. This height is h. So here position is 0, here position is h, and this is highest position. Okay, where final velocity is 0, but we are representing in distance time graph. Again the body returns back. Again distance covered is h, but direction is negative, but distance is scalar. Distance can never be negative. Distance is scalar. For a moving body, distance always increases. Distance can never decrease. Okay. So this time is t, means t is equal to time of ascent. Okay. Thereafter, again velocity, again the distance increases in opposite direction, but distance is scalar. It's not required to take direction wise. So again distance increases. So how will show? Accelerated motion. Accelerated motion means parabolic curve. So again distance increases. So this total height is 2h, and again this time is t, means time of descent, and total time of flight is 2t. Total time of flight is 2t. So for accelerated motion, if you are representing displacement time graph or distance time graph for accelerated motion, the graph will be parabolic. See, for accelerated motion, we have discussed tan theta is not constant. Tan theta changes means theta changes. Okay. So accelerated motion, first distance goes on increasing, reaches at a height h. Thereafter also while returning, distance again increases, and total distance is 2h. Clear? Okay. Then the final question in this lecture, question number 7. Displacement time graph. Graph is like this. Displacement and variation of time. Okay. Let this displacement is, this is 0, this is 20 meter. Okay. Suppose this time is 2 seconds, this time is 4 seconds, and finally this time is 6 seconds. Here you may take 5 seconds. 6 seconds, this is 5 seconds. Okay. This is origin, and this position is again 10 meter but in negative direction. 10 meter in negative direction. Okay. So what is asked? Find total distance. A bit find total distance. B bit find displacement. C bit find average speed. D bit find average velocity. So 4 bits find total distance, find displacement, find average speed, find average velocity. Let's discuss bit A. To find total distance, very easy, just see. In time 2 seconds, the body has covered a distance 20 meter. So total distance is equal. In 2 seconds, the body has covered a distance 20 meter. Plus, again, in this 2 seconds, means from 2 seconds to 4 seconds, body has returned back to original position, means again distance travelled is 20 meter. Distance can never be negative. Okay. In next 1 second, from 4 seconds to 5 seconds, distance covered is 10 meter plus 10 meter. Then from 5 seconds to 6 seconds, again the body has returned back to original position. So again 10 meter. So total distance is 20 plus 20, 40 plus 20, 60 meter. Total distance is 60 meter. Okay. Then will be displacement. What will be displacement? See, this is initial position. S is 0 when time is 0. So final time is 6 seconds. The body has returned back to original position. Here also position is 0. So body has returned back to original position means total displacement is 0. And let's see average speed. Average speed. And as we know, average speed is a ratio of total distance to total time. And total distance is, we have got 60 meter. And total time is from 0 to 6 seconds, means total time is 6 seconds. So it is 10 meter per second. And d bit, average velocity. C. Total displacement is 0. Velocity is displacement upon time. So average velocity is 0. So this lecture was too easier for you. And these are fundamental questions on distance time or displacement time graph. In next lecture we will discuss some numericals based on velocity time graph. And I hope you have enjoyed the class. And again, the next lecture VT graph is very important. We will discuss the maximum concepts. Thanks my children. Thanks.